Question 4c. Katie is one of 10 members of a social club. Each week, one member is selected at random to win a prize. Part 1. What is the probability that in the first 7 weeks, Katie will win at least one prize? Katie is one of 10 members in the social club, so the probability of a win in any given week is 1 out of 10 or 0.1. Now, by the law of complements, the probability that Katie wins at least one prize in the 7 weeks is equal to 1 minus the probability that Katie wins no prizes in the 7 weeks, which equals 1 minus 0.9 to the power of 7, which equals 0.5217031, or approximately 52.2%. Part 2. Show that in the first 20 weeks, Katie has a greater chance of winning exactly 2 prizes than of winning exactly 1 prize. The probability that Katie wins exactly 1 prize over 20 weeks using the binomial distribution is equal to 20 choose 1 times 0.1 to the power of 1 times 0.9 to the power of 19. Now 0.1 is the probability that Katie wins a prize in any given week, and 0.9 is the complement of 0.1, which is the probability that Katie loses in any given week. And that's approximately equal to 0.27017033435, or approximately 27.02%. Now the probability that Katie wins exactly 2 prizes over 20 weeks, again using the binomial distribution, is equal to 20 choose 2 times 0.1 squared times 0.9 to the power of 18. Notice that the sum of the indices 2 and 18 should equal this number here. And that equals 0.28517987071, or approximately 28.52%. Therefore, the probability that Katie wins exactly 2 prizes over 20 weeks is greater than the probability that Katie wins exactly 1 prize over 20 weeks as required. Part 3. For how many weeks must Katie participate in the prize drawing so that she has a greater chance of winning exactly 3 prizes than of winning exactly 2 prizes? Using the binomial distribution, the probability that Katie wins exactly 3 prizes over n weeks is equal to n choose 3 times 0.1 cubed times 0.9 to the power of n minus 3. And the probability that Katie wins exactly 2 prizes over n weeks is equal to n choose 2 times 0.1 squared times 0.9 to the power of n minus 2. We want to find a value for n such that this probability, the probability of 3 prizes, is greater than the probability of 2 prizes. So we're going to solve for n the inequality n choose 3 times 0.1 cubed times 0.9 to the power of n minus 3 greater than n choose 2 times 0.1 squared times 0.9 to the power of n minus 2. Expressing the combinations on both sides of the inequality using factorials, we have n factorial over 3 factorial times n minus 3 factorial times 0.1 cubed times 0.9 to the power of n minus 3 greater than n factorial over 2 factorial times n minus 2 factorial times 0.1 squared times 0.9 to the power of n minus 2. Now we can simplify this inequality by dividing both sides by n factorial times 0.1 squared times 0.9 to the power of n minus 3. And the inequality becomes 1 over 3 factorial times n minus 3 factorial times 0.1 greater than 1 over 2 factorial times n minus 2 factorial times 0.9. Now we can rearrange this inequality by multiplying both sides by this denominator, so 2 factorial n minus 2 factorial, so we can have the factorials all on one side, and we can divide both sides of this inequality by 0.1. So we end up with 2 factorial times n minus 2 factorial over 3 factorial times n minus 3 factorial is greater than 9. Now multiplying both sides of this inequality by 3 factorial over 2 factorial, we end up with n minus 2 factorial over n minus 3 factorial is greater than 27. And n minus 2 factorial over n minus 3 factorial simplifies to n minus 2. So we have n minus 2 is greater than 27. Adding 2 to both sides, we get n is greater than 29. Hence, the smallest integer n that's greater than 29 is 30. Therefore, Katie must participate for at least 30 weeks, such that the probability that she wins 3 prizes or exactly 3 prizes is greater than the probability of Katie winning exactly 2 prizes.